Hi everyone, this is David Blakey again. The name of this short video is Python Regular Expressions Character Classes. What's a character class? Well, so far we've just looked at patterns that are literal characters. That is, if we're looking for hello comma world, it's H followed by E followed by L followed by L followed by O followed by comma followed by space. Well, you get the idea. These patterns are literal, and so we're really just looking for substrings, and aside from the use of the anchors, which are pretty good, well, actually, I take it back. I think everything that we have looked at so far in regular expressions can be handled by string methods. We have starts with, ends with, the double equals sign to compare strings, and so there's nothing new under the sun here at the moment, or I should say there's nothing new about what we've seen so far. But what I'm going to look at, show you next, is something that string methods cannot possibly handle, and that is the idea of a class of characters, or how should I put it, a character a regular expression entity that can match on any of a number of different characters, something we call a character class. For example, the digit character class. We can look for a digit character within this string and see if there's one in there. As you can see, there isn't one, right? There isn't one. So if we run it, we'll see no result. But if we put a digit somewhere in the string, we'll find it does match. Now look at this \d. This is the first character combination that we've seen that signifies something specific. \d doesn't mean a backslash followed by a d in regular expressions. Regular expressions see a \d as meaning a digit. In other words, the \d by itself will match on one digit. It'll match on one digit. We can quantify it later. If we wanted to match on 2 digits, we could do \d. All right, here's a quiz for you, going back to what we said in the first video. Notice that we have this 5444444, and we've got in our pattern 2 digits. 2 digits. So my first question to you is this going to match? Is this going to match? We have many more than just 2 digits. So is this going to match? It's a good question, right? Maybe pause the video if you don't know and think about it. And think about what we've talked about in the past. All right, let's go ahead and test it. Yeah, it matched. Sure it did. There's no reason it shouldn't. Remember, we're talking about a substring match. That was the first thing. Or that was the second thing, rather. Regular expression matches are on substrings. In other words, this is looking for 2 characters, right? And it finds two digit characters right here. It's looking for 2 digit characters. And it finds the 2 digit characters right here at the beginning with 5 and 4. So it matches. It matches. It absolutely does. If you thought differently, you might be thinking, oh, well, it's looking for 2 digits, so that must be like a 2-digit word, like a single word with parentheses around it. But no, remember, again, the regular expression engine begins at the first character. It looks at the first character and it says, okay, am I a digit? No? Okay, let's go to the next one. Here's the next one. Is that a digit? No. All right, let's keep going. Is that a digit? No. Okay, let's keep going. And it'll keep going until it finally comes to a digit. And then it'll look for the second digit and find it and say, I matched. I matched successfully. Terrific. All right, here's your other quiz. Also going back to something we said in the first episode. What if we screw this up by adding a space in the middle? We still have the 2 digits, so will it match? If you're not sure, pause it and think about it. Will it match? Think about what I've said before about what the regular expression engine does. Okay, are you back? The question is, does digit match on 5 space 4? And the answer is no, it doesn't. And why? Because of the other rule we gave you, which was that a match needs to be consecutive. Now some might ask, how could we match on this? Well, one way would be to simply add the spaces in the middle. There's digit, space, digit, and that's exactly what we have in there. And so it does match. Now later, a little bit later, we're going to look at how to match on, let's say 1 or more spaces. But for now, we'll just stick to this character class and the two others. We are going to look at a space character class. So digit matches on anything, and we could put this up here. We could say the digit character class matches on, and then let's just put a list. The idea of a class, also a synonym for type, and these are not Python words, this is all regular expression stuff, is that a character class contains a set of members in the class. The set of members here are 0, 1, 2, 3, 4. In other words, the 10 digits are members of this class. So when we put a \d within our pattern, we're saying to regular expression engine, look for any of these. Look for any of these. It'll look at each character and say, are you one of these 10? Are you one of these 10? Etc. When it finds one that is this a member of this 10, then it's a match. And that's how character classes work. The other two character classes that we'll look at, and actually then we'll look at its two partners as well, or three partners, so there are 6 altogether that we'll look at, what we call the built-in character classes, are known as the word character class and the space character class. And each of these represents a set of characters. The word character class matches on A to Z, and 0 to 9. And it also matches on an underscore. This has its roots in the whole the whole sysadmin culture, Unix culture that gave birth to regular expressions. I didn't mention it in the introduction, but regular expressions are available everywhere. They're not just on Python. They're available in Perl, from which Python takes its feature set. They're available in JavaScript, VBasic, Java, and Python. And they're so useful. They're so incredibly useful that we need to have them at our side at all times. All right, let's look at these other two character classes, the word character class, the space character class, a space, a tab, and a new line. So there are 3 characters within the space character class. And all of these come in pretty serious handy as we're doing our work. The word character class, like I said, it borrows, probably decided on its set a long time ago, and a decision was made by sysadmins who use these characters within file names and for other purposes. The A to Z, and 0 to 9 underscore is the set. Any character that falls within those character ranges or that membership is part of the class and will match. A to Z, notice that I put in a lowercase a to z and then an uppercase a to z. That's because these characters are fundamentally different characters, fundamentally. In actuality, they're totally different characters that happen to be associated by alphabetical means. But as far as Python is concerned, and most other languages, they're different characters. These characters appear in different places on the ASCII table, and they're simply other characters. So we have to specify them directly. Rather than say A to Z, we could go ahead and list out everything within the character class. Okay, or we can use the range that we're using here with capital A to Z. But it's all about membership, right? The \W, when it appears in a regular expression, matches on a word character. That means it'll match on a letter. It means it'll match on a number. And it also means it'll match on the underscore. So sometimes we use that for names. The space character class matches on a space, a tab, or a new line. And we use it generally to talk about stripping white space at the end of a line, or just finding white space of any kind within a string. It's often hard to tell what you're dealing with when you look at a string and it has some spaces in it. You never know with a tab whether there's a tab in there or whether it's all spaces. You have to go in and check. Well, the space character class is designed specifically to match on those spaces. Okay, in addition to that, we have two other things that we really need to talk about. One is the custom character class. And let's talk about what that is. The custom character class is basically a character class, just like the digit or word or space character class, but you can customize the list. In other words, you could say, I just want to match on lowercase letters. That's your character class. You'd say, I want to match just on any letter at all. That's your character class. If you wanted to match just on, let's say, the numbers 1 through 5, because you're dealing with hex, that's a character class. In other words, the presence of this within a pattern will match if it finds a character of that type. So going back up to, let's say, up here, we could look for 2 digits together, and that'll work. Actually, I better... let's take a look. So that matched. And we could do that just as easily by putting in a special character class of our own. Let's see, and we'll do it twice. So now we're saying any number between 1 and 5 is fine. And we're looking for 2 of them, actually. And, let's run the match and see that it matches. I'm going to go even further and say that space and space, world, let's say, that should match 2. The 1 to 5 is specifying it. And as you can see, you can't put 1 and expect it to match on more than one number. That's not going to match. Why doesn't it match? Because we're looking for a space followed by a digit 1 to 5, which we find, followed by a space, and then world. Oh, we forgot the other digit. I specifically forgot the other digit because I didn't want you to get lulled into thinking that because a character class contains a set of numbers, that it needs to match on, that it will match on more than one letter. We can use quantifiers later, which will change the number of times it'll match. But for now, the presence of a character class, a custom character class, that contains a range really matches on just one character. In other words, the character itself, it matches on just a single character. Let's try this by going 1 to 8, let's say. Is that going to match? Well, sure it will, because 4 is within 1 to 8, and before it, 5 is within 1 to 5. But what if we were to say 5 to 8 here? Would that match? Well, certainly not. That would not match at all. Certainly not. If we go ahead and change the range again, so it's 1 to 8, well, that'll certainly match. Sure. So you can see that this character class, this custom character class, matches on any one character, but it can be any character within the set. Another interesting, we could, another interesting, is it interesting? Is this idea of, let's say, matching on just letters. I've run into this need quite a bit, and there's no built-in class for it. It's simply not available. There's many times when I want to match on a letter. I'm not interested in matching on a number. And if I have the word character class at my disposal, it may incorrectly match on numbers from time to time. Or the reverse. You know, we could be doing this with digits. But what we're saying here is that this will match on just one, and it'll match on any one letter. So we can customize them and do whatever we want with them. We could say A-E-I-O-U, and that'll match on a vowel, for example. And then the space. Space character class works on a space. Here's a quiz. Does this match? Sure, I don't have to run it to see that it matches. It's looking for one space, and there is one space within it, so we're fine. The last thing I need to talk to you about with these character classes is the idea of the inverse character class. So here we have a custom character class, A to Z. Here's some custom character classes. Just let's say do this one. But then we have this concept of an inverse match. That is something that does not match. Here is the inverse character class, not a digit. Wow, cool. Not a digit. In other words, it will match on one character. Matches on one character just like any other character class. Matches on one letter and only one letter until we repeat it or quantify it, which we'll look at next. But this matches on anything that's not a digit. This one matches on anything that's not a word character. This matches on anything that's not a space. Let's do a little testing to see. Here's a test for you. Again, with this whole logic thing, note that the pattern is a non-digit character. And the string is hello, comma, space, 54, space, world. So the question here is, does this match or not? Does it match? Does it match? Look again. We're trying to match the D pattern, the capital D inverse character class, that is the non-D, a non-D character, within my string, hello, comma, 54, world. Will it match? Will it match? Take a pause and think about it. Don't worry about getting it wrong. Just take your best guess. That'll help your understanding. Okay, we back? Check it out. Question is, will it match? Will the non-digit character match within hello, comma, 54, space, world? Will it match? Well, let me ask you something. Is the first character in my string, is that a non-digit? Yeah, sure, it's a non-digit. It's an H. It's not a digit at all. So it is a non-digit. So right now, the \D will match on the H, and it doesn't go any further. You can't see that, and it doesn't give you any clue of how far it matched. But I'm telling you right now that this \D matched on the H because it was the first character that was a non-digit. Also happened to be the first character. And that's how the inverse character class can work. How would we use something like this? Well, let's say we've got a string and we don't know whether it's all numbers or not. Now, again, we could use a string method for this, but bear with me. This isn't necessarily the right time to use it. And, of course, we have the option of much more complex patterns that where string methods wouldn't be of use. But if it's looking for a non-digit, then we could use it for validation. So let's say that my string is some sort of user input. And why don't we just call it user input? And we will change this too. And we'll change this too. Okay, great. We're using a user input as a label. The user input's 54. We want to try to verify that the string is all digits. The user input something and it was supposed to be a number, and we need to check that. Again, we have a string method that does that, but let's not worry about that. In other words, what we want to say is, let's say we could say if it contains an odd digit, then print invalid input. All digits, please. And we can pretend that the program then loops around and asks the question again. So let's try it out. Oh, let's see. Looked for a non-digit, but did it find one? No, because they're both digits. So the user input was correct. Let's screw up the user input by putting a space in there. Does that match? All right, invalid input. All digits, please. Now you may say, but wait a second. I only have digits in there. All I have after that is a space. That's not a character. Well, of course, a space is a character. A space character is a specific character. It's a character that belongs in the ASCII set. It's a character that we encounter all the time, and it indicates the movement of the cursor from one position to the next. It helps separate words. It's a vital character to everything we do, and it's a perfectly legitimate character. It's not just some loose space sticking out over the end. So when it looks for a non-digit, Python looks at the 5 and says, well, that's a digit, so that's not a non-digit. And then it looks at the 4 and it says, well, that's not a non-digit. And then it looks at the space and it says, well, that's a non-digit. Terrific. I match. I match. Oops. Wait a second. Yeah, right. I match. And I match means that's bad input. So we get invalid input. Okay, how else can I tease you and get you to try to uncover some of your incomplete understandings? Well, let's take that space at the end. Perhaps we're only interested in knowing whether there's a space at the end. If there's a space at the end of the string, then we want to do something about it. Maybe we'll strip it off, or maybe we'll point it out to the user. Your string that you typed ended in spaces, and I can't use spaces. Please input again. How would we do that? Well, we'll look for a space at the end. That's one way to do it, right? We could look for a space at the end, and if that was the case, we could say invalid input. Or we could see if there's a non-space at the end, and if there's a non-space at the end, we can say valid input, no space at the end, right? Of course, this isn't going to match, right? It doesn't match at all. Why? Because it's looking for a non-space at the end of the string. And is there a non-space at the end of the string? No, there's a space at the end of the string. So that's not helpful to us. Or rather, I'm sorry, it's not that it's not helpful to us. It's something that it doesn't match, right? There's a non-space at the end. No, I'm sorry, but there's not a non-space at the end. There's a space at the end. So that means we'd have to change our thing again. If we're looking for a non-space at the end, we can say valid input. Wait, I think that's what we did. Yes, it is. Let's try it again. So does it match? Well, okay. It would only match if we had a non-space at the end. A non-space at the end means valid input. We had a non-space at the end. Okay, I don't know if that's clear or not. I hope it is. The last bit that I want to explain to you is the idea of a negative character class. Negative or an inverse character class is exactly the same concept as a non-digit, a non-word, or a non-space. Here we can say, is it a non-letter, for example? Now notice what's different about this. With this character class, we're looking for a non-digit, or a non-letter, a non-letter. Do you see the caret there? Now look closely at where the caret is and make a note. You can see that the caret is not at the beginning of the match, right? Or the beginning of the pattern. If it were at the beginning of the pattern, it would force the pattern to match at the beginning of the string. But that's not the case here. The caret is inside the square brackets. So it matches on anything but a letter. It'll match on anything but a letter. Let's see. Let's find out if there's a match of anything but a letter. If you want to do a test, press the spacebar and ask yourself whether this will match. As you can see, the non-letter character class simply says, I will match on a non-letter. So is that a non-letter? Yes. So does it match? Absolutely. Does it need to be at the beginning of the string? Absolutely not. Let's put a bunch of letters in here. Now my question to you, will this match? Will this match? What's it looking for? The regular expression engine is looking for a non-letter. So again, let's why don't you hit the space bar if you wish and tell me whether it's going to match. As you can see, it's looking for a non-letter, right? So it looks for the non-letter and doesn't find it here. Then it looks for the non-letter and doesn't find it here. Then it looks for the non-letter on and on and on until it gets to here. Then it says I'm going to look for a non-letter, and it looks for a non-letter here, and it finds one. There's a non-letter. Doesn't matter whether it's at the beginning or the end. It doesn't matter whether it's the whole string or not. It only looks for one non-letter character within the string. So it's doing that consecutive thing. It's doing that substring behavior where it just tries to match the pattern to somewhere within the string. And that's why the negative character class of not a letter works here. Okay, that's it for character classes. Hope it was clear. Please always, as always, give me feedback about these videos and tell me how they're working out for you. Thanks. Talk to you soon.